Hello everyone, I'm Christian Sumini and I'll report storm drainage sections 1101 to 1104. So first, let us define what is storm drainage system. It is a network of structures, channels, and underground pipes that carry storm water or rainwater to ponds, lakes, streams, and rivers. The network consists of both public and private systems. Storm drainage system is an integral part of the system in the country. It is designed to control the quantity, quality, timing, and distribution of storm runoff. It's not part of which carries water and waste from drains, like sinks, bathtubs, showers, and toilets, to a treatment plant to be treated and filtered. Storm drain versus sewer. The sanitary sewer is a system of underground pipes that carries sewage from bathrooms, sinks, kitchens, and other plumbing components to a wastewater treatment plant where it is filtered, treated, and discharged. However, the storm sewer is designed to carry rainfall runoff, and so as we can see in the picture, there are two underground pipes. On the left side, there is the sewer pipe. So, ang nagadaan dyan na waste is galing sa sinks, kitchens, and other plumbing components. While on the right side, that is the storm drainage system. So, mainly rainwater lang nagadaan dyan. How do storm drain systems work? The storm drainage system helps prevent floods by diverting rainwater into nearby waterways. The water and pollutants flow into storm drains and through underground pipes directly to the nearest stream, pond, or water reservoir. Now, to further understand on how the storm drain systems work, let us watch this short video.
Did you know the biggest source of water pollution is contaminated stormwater? More than 500,000 litres of rainwater falls on an average suburban block each year in Canberra. That's more than 2,500 full bathtubs. And during a big summer storm, about 90 bathtubs of water can fall in less than 30 minutes. So what happens to all that water? Well, some of it ends up in rainwater tanks and some soaks into your garden. But most of it becomes runoff that collects all sorts of pollutants, including soil, leaves, dog poo, cigarette butts and other rubbish, before disappearing into the drain. All sorted, right? Well, no. Thanks to a large network of concrete channels and underground pipes that move stormwater rapidly out of the suburbs to prevent flooding, it's only a short trip to rivers and lakes where all these pollutants can cause problems, like blue-green algae. But it doesn't have to be this way. We can all help by making sure only rain goes down the stormwater drain. And the Australian and ACT governments are working together to build new wetlands and other green infrastructure designed to improve the quality of water entering our waterways. Water from suburban blocks runs into drains, where pollutant traps and trash racks catch most of the big rubbish. When that stormwater is diverted into wetlands, ponds and rain gardens, instead of travelling straight into our waterways, nature takes over. Sediment has a chance to settle and plants break down some of the harmful nutrients. Rain gardens look just like a garden on the surface and are mostly dry. Plant soil and gravel filter the stormwater and remove algae-feeding nutrients. Restoring creeks to their natural state helps to slow and filter runoff and reduce erosion, which means less sediment running into our waterways. Finally, the treated stormwater reaches lakes and rivers cleaner, cooler, and in smaller volumes, which is good for the fish, plants, wildlife, and for us. What can you do to help keep our waterways clean? To find out more, go to act.gov.au/H2OK.
Section 1101 General. Storm drainage are required for roof areas, courts, and courtyards to collect storm water and discharge the storm water to an approved point of disposal not in conflict with other ordinance or regulations. Section 1102 Rainwater Systems Materials. Rainwater downspout or conductor piping placed within the interior of a building inside a vertical pipe chase or run within a vent shaft shall be of cast iron, galvanized steel, iron, brass, copper, lead, Schedule 1000 PVC, DWV or other approved materials. So, so since the piping is exposed to weather like rain and temperature, it is prone to corrosion. So it is important that the materials used for the piping should be non-corrosive like iron or brass or copper. Next, rainwater downspout or conductor located on the exterior side of a low-height building shall not be less than 26 galvanized sheet metal. The bottom of the conductor draining over the catch basin, storm drain, or storm sewer is protected from damage by connecting a stronger material such as a steel pipe or a cast iron at its lowest section. Next, rainwater piping located within a medium-height building basement area shall be of galvanized iron pipe, Schedule 30, cast iron soil pipe, Schedule, type the DWV copper tube, Schedule 40 ABS DWV Series 1000, PVC, DWV or other approved materials. Next, downspouts for high-rise buildings shall be of stronger pipe materials to resist the high hydrostatic pressure inside the vertical downspout installed within the pipe chase, which has no intermediate branch from the roof of the ground level. So when we say hydrostatic pressure, it is a pressure exerted by a fluid at equilibrium at a given point within the fluid due to the force of gravity. Hydrostatic pressure increases in proportion to depth measured from the surface because of the increasing weight of fluid exerting downward force from above. Next, rainwater piping commencing 0.6 meter from the exterior of a building may be of suitable approved materials permitted in the installation requirements of this code. So as mentioned from the last slide, the approved materials is of galvanized steel or iron, copper, PVC, CPVC or PE. Sections 1102.2 Connections and Installations. Rainwater piping shall not be used as soil, waste, and vent pipes. If you decide to allow rainwater pipes to discharge onto the ground, you need to make sure the water will not damage foundations. Water must not be discharged into a foul drain or sewer. Next, rainwater piping installed in locations where they may be subjected to damage shall be protected. So when we place or lay out our piping system, it should be placed to a position where water drains properly and away from the house, and also away from possible damage. Next, roof drains, overflow drains, and rainwater pipings used in building construction shall be previously tested and accepted in conformity with the provision of this code. Roof drains are commonly found on the roof near the center of the building, but a certified architect or engineer will determine their placement by evaluating the locations on the roof that will collect the most water. Your roofing contractor can clear debris and vegetation from the dry sump area, drain bowl, and drain basket. But if the drain line itself is clogged, a professional plumber needs to be called in. Section 1103 Roof Drain Materials Roof drains shall be of cast iron, copper, or other corrosion-resistant materials. Strainers Roof drains shall be equipped with strainers extending not less than 2 mm above the surface of the roof, immediately adjacent to the drain. Dome-type strainers shall have a minimum total net inlet area of 1/2 times the area of the outlet pipe to which it is connected. So, what is the importance of strainers? So, ginagawa niya is gina-filter niya yung mga waste sa roof para hindi siya mag-clog and hindi masira yung piping ng system natin. Next, roof decks strainers for use on sun decks, parking decks, and similar occupied areas shall be approved flat surface type which is level with the deck. Such drains shall have a total net inlet area not less than 2 times the area of the outlet pipe to which the drain is connected. Next, roof drains passing through the roof into the interior of a building shall be made watertight at the roof level by the use of CI drain with integrally cast water stop ring around the outside of body and placed at mid-depth of the concrete roof slab, and the installation of a clamp suitable flashing materials around the drain. Next, in all cases, the outlet connections are inside caulk or female screwed. So when we say female screwed, each half of a pair of mating connectors or fasteners is conventionally assigned the designation male or female. The female connector is generally a receptacle that receives and holds the male connector. Next, Section 1104 Sizing of Rainwater Piping Vertical rainwater piping shall be sized in accordance with Table 11-1, which is based upon maximum depth in millimeter or rainfall per hour falling upon a given roof area in square meter. Consult local rainfall figures to determine maximum rainfall per hour. Normally, a 102 mm per hour rainfall intensity is used around Manila area. Next, vertical wall areas, where vertical walls project above a roof so as to permit storm water to drain to adjacent roof area below. The total roof are considered may be computed from Table 11-2 as follows. For one wall, add 50% of area of the wall to the area. For two adjacent walls, add 35% of the total wall area to the roof area. Two walls opposite each other and of same heights, add no additional area to the roof area. Two walls opposite to differing heights, add 50% of wall above area above top of lower wall to the roof area. Walls on three sides, add 50% of area of the inner one below to the top of the lowest wall, plus allowance for area of wall above top of the lowest wall per sections 1104.2.2 and 1104.2.4. Walls of four sides, no allowance for wall areas below top of lowest wall. Add for areas above top lowest wall per 1104.2.1, 1104.2.2, 1104.2.4, and 1104.2.5. The area of the side of a tall building exposed to rain is taken as 1/2 of the gross area. So that's all. So here are my references. Thank you.